Have you ever wondered what it's like beneath the surface? It is a macrocosm of biochemical systems that we rely on every day. Soil is a mixture of organic matter, water, air, chemical nutrients, and geological material, and is home to plant and animal life. The soil cycles essential nutrients and provides the building blocks for strong ecosystems and sustains all life on Earth. Nitrogen is a life-supporting nutrient, and during a major part of its cycle, it calls the soil its home. But nitrogen makes up 78% of the atmosphere, I hear you call. Yes, it does. But the nitrogen in the atmosphere isn't in a usable form. All biological organisms require nitrogen in some form to synthesize amino acids, nucleic acids, and proteins. So how do we get it in a usable form? With the help of bacteria in our soils. In soil live nitrogen-fixing bacteria and archaea called diazotrophs. They break apart the nitrogen bonds and add hydrogen atoms, creating ammonia, or NH3. The ammonia is then converted to ammonium, or NH4+, with the addition of another hydrogen atom. This process is also facilitated by diazotrophs. They benefit from the process as they gain metabolically useful energy. The ammonium goes through the process of nitrification, where ammonium becomes nitrite with the help of bacteria, and then nitrate. The nitrates are then taken up by the plant via assimilation, where they're utilized for growth and food production. The nitrogen that is not used is then denitrified by the bacteria, and it floats off into the atmosphere. This process is the lifeblood of food production. In order to increase the rate at which nutrient-rich foods are grown, humans have created numerous technological advancements. In 1908, the Haber-Bosch process was developed, a man-made version of the nitrogen fixation process, synthetic, fast, and abiotic. These synthetic nitrogen fertilizers drastically increase agricultural production. Though, the use of these fertilizers in large quantities influences the nitrogen cycle, sometimes creating chemical imbalances throughout. Too much or too little nitrogen proves harmful, as too much oxidized nitrogen in the atmosphere can yield a cascading effect, increasing the chance of acid rain, water eutrophication, loss of species, and human health concerns in relation to water. Yet, the equilibrium of nutrients in the world's ecosystem determines our food supply. Ultimately, what's happening in the soil affects what's happening on the surface. Both natural processes and human activities alter the concentration of nitrogen in the atmosphere, the soil, and the water that we drink. Remember, you are not an individual when it comes to biochemical systems. On each bite and with each breath, nitrogen flows through us.